Stoichiometry. Something you probably never thought would ever be relevant in your life until you started taking chemistry at Lassiter.
And if you're thinking, I am taking chemistry at Lassiter, but stoichiometry still isn't important in my life, then you're absolutely right.
Except for the fact that you're absolutely wrong. Stoichiometry is a measurement of things that go into and come out of a reaction.
Okay, but I still don't see why that's important for anyone to know.
Alright, well, let's say that you wanted to be a rocket scientist. In rocket science, what goes into the fuel is crucial. We, as rocket scientists, must be very conscious as to what we use to fuel our rockets, how we store those things, and what do we get from what we put in.
Okay, this is starting to make sense because we don't want to put in too little of something that causes our rocket not to make it into space, and we also don't want too much of it that could cause it to blow up or something.
Exactly. Speaking of, there actually was an incident where the fuel proportions were off and the launch of a NASA rocket failed. NASA currently fuels their rockets with liquid hydrogen and liquid oxygen, and if these two substances aren't combined in the right ratios, it could lead to disaster.
Right, I heard about that. I think they didn't put enough liquid oxygen into the fuel, so the rocket ran out before it was supposed to.
And this is where stoichiometry comes into play. What if I told you we could calculate for ourselves what actually happened during the launch using this method?
Then I guess that would be kind of useful.
Alright, so let's get the information we need.
According to the NASA website, they used 2,000 pounds of hydrogen and 12,000 pounds of oxygen during the flight. This reaction produces water and energy in the form of heat. The rocket uses the energy as fuel, but something caused the fuel to run out.
And I can show you exactly how that happened. First, you must write out a balanced equation for the reaction. The balanced equation is 2H2 plus O2 yields 2H2O and energy in the form of heat. Next, before using any stoichiometry, we must convert pounds to grams by using dimensional analysis. So we convert 2,000 pounds of H2 into 907,200 grams of H2. 12,000 pounds of O2 becomes 5,443,100 grams of O2. Now we can begin the stoichiometry process. We are going to find out which element limited the reaction by determining how many grams of water each element can produce.
Oh wait, I remember that. Don't we use the stoichiometry roadmap to help us? This roadmap tells us to convert from grams of the known substance to moles of the known substance using the molar mass. Then we convert from the moles of the known substance to moles of the unknown substance using the mole ratios. Finally, we convert from the moles of the unknown substance to grams of the unknown substance using the molar mass.
That's exactly right. Now let's put it into action. As you know, we're starting with 907,200 grams of H2 and 5,443,100 grams of O2. I'm going to show you how to get from grams of liquid hydrogen to grams of water, and then you'll practice by doing the same, grams of liquid oxygen to grams of water.
Sounds good.
So we are starting with 907,200 grams of H2, and we are going to convert that to moles by using the molar mass of H2, which is 2.02 grams, and putting that under 1 mole of H2. Then we are going from moles of H2 to moles of H2O by using the mole ratio, which we get from the balanced equation. Finally, we will go from moles of H2O to grams of H2O by taking the molar mass of H2O, which is 18.02 grams, and putting that over 1 mole of H2O. That will give us the calculation that 8,093,000 grams of H2O can be produced from 907,200 grams of H2. Now you do the oxygen.
So we will start with 5,443,100 grams of oxygen that we will convert into moles of oxygen by using the molar mass of oxygen, which is 32 grams. We will put that under 1 mole of O2. Then we go from moles O2 to moles H2O by using the mole ratio. Finally, we will convert from moles of H2O to grams of H2O by using the molar mass of H2O, which is 18.02 grams. When we multiply out the equation and divide by the bottom, we get the calculation that 6,130,300 grams H2O can be produced from the O2 that was given.
So, we know that less water is produced by the liquid oxygen in the reaction. Therefore, oxygen is the limiting reactant.
And that tells us that because they did not put enough oxygen, the fuel ran out before the rocket reached its destination.
And it didn't take rocket science to figure that out. Now do you believe that stoichiometry has some relevance in your life?
Yeah, I guess you're right, Miss Whiteman. We can use chemistry in our lives.
The more you know! Currently, fuels...
Oh, you can't be Michaela!
Limited.
Oh, wait. I remember that. I said, oh wait, so I can't.
Do NASA people even wear lab coats? No. The NASA rocket failed?
Yeah.
Yeah.
Yeah, it failed.
Yeah,
It
it
did.
failed.
Yeah.
NASA currently fuels their rockets with mistakes.